Alright guys, welcome to our new unit, Unit 3, Limits. So, limits are kind of foundational to calculus. We started off with derivatives and integrals just because it's a big set of rules that we're going to use all year long, and so I wanted to start with those early so that we can be familiar with them and start using them early on. But really, the real heart of calculus is limits, okay? And it's actually, limits is where derivatives and integrals even come from. So limits is really the birthing ground, if you will, of all calculus concepts. So this is where most calculus classes actually begin, and I'm a little bit unorthodox in the way that I start with derivative and integral rules, but like I said, there's a reason for that. But anyway, limits is really the beginning place of calculus. So we're going to talk about what a limit is first today, and then we're going to talk about how you guys can find limits using tables and graphing calculators. So let's begin. So sit for a moment. I would encourage you guys to pause the video here and see if you can find f of 3. Now pay attention to the fact that's not saying f prime of 3. I'm not asking you to find a derivative. I'm just asking you to find f of 3, which means plug it in and see what you get. Alright, so if you were to plug 3 into the top, you would get 0, because when you plug in 3, you get 8 times 3, which is 24, and 24 take away 24 leaves us with 0. So the numerator is 0. And if I plug 3 into the bottom, I get 3 squared, which is 9, plus 3 times 2 is 6, which is 9 plus 6 minus 15. Well, that's 0 again. Now you're not allowed to have 0 in the bottom, and so what we would say is that this is undefined. It doesn't exist. Okay? So the function does not exist at that point. Now, let's go a little bit deeper with this question here. We're going to approach it from a different perspective, though. All right? So I know I'm not allowed to plug in 3. When I plug in 3, I get no answer. Okay? So instead of trying to figure out what does my function equal when it equals 3, we're going to instead we're going to approach 3. We're going to get closer and closer to it. Because although the function can't equal 3, it can be anything else. So like for instance, let's go ahead and plug in, I'm going to plug in 2.9 and 3.1. Now you guys agree that 2.9 is really close to 3, right? And so is 3.1. If I were to actually plug that in, now I'm not going to take the time to show all my work for that, but if you plugged in 2.9 and 3.1, the two answers you would get would be this. So if you plug in 2.9, you get 1.0127. So pretty much you get 1, right? And if you plug in 3.1, you get pretty much 1. Now, that's interesting. So if I plug in two numbers that are really close to 3, I get two answers that are really close to 1. Let's plug in something even closer. What's something even closer to 3 than 2.9 and 3.1? How about 2.99 and 3.01? Those are even closer to 3. If I plug those in, I'm still getting something really close to 1. In fact, this number is even closer to 1 than this one is, and this number is even closer to 1 than this one is. Doesn't actually even look like it is. Let's keep going and see though. 2.999 and 3.001. We're going to get even closer to 3. As you can see, the closer I get to plugging in 3, the closer the y value or the output value is to 1. So here's what I'm trying to demonstrate for you guys. No, the function cannot equal, well, the function doesn't equal anything when x equals 3. It's undefined. But here's what's really interesting. As x gets closer and closer to 3 from the left and also from the right, the y value seems to be getting closer and closer to 1. So even though it doesn't get there because it's undefined at 3, it's approaching 1. And that's what we call a limit. Even though it doesn't exist at 3, it approaches a value at 3, and the value that it approaches is 1. Okay, so that's what a limit is. The limit of a function, L, is L if f of x approaches L as x approaches c from the right and from the left. Okay, so in this case, my L is 1 because f of x seemed to be getting closer and closer to 1 both from the left and from the right. And my c value is the x value here. Well, actually, let me change my statement here. My c value is the 3. And c equals 3. So as I get closer and closer to 3, as x gets closer and closer to 3, my L value gets closer and closer to 1. And that's, so let's go back to that last slide then, so that makes a little more sense. So the limit of a function is L. So the limit of that function in the last slide was 1. The limit of a function is L if f of x approaches L as x approaches c. On our last page, that was 3. And it has to be from the right and from the left. Now here's the notation we use for that. Here we put the function that we are using. Here we say what number x is approaching. So on the last slide, x was approaching 3. And the answer I get out is the y value that we are approaching. So back to the slide here, the y value I was approaching, or the output value, was here, and it was getting closer and closer to 1. So that's what a limit is. Now, I don't want you guys to think that in order for a limit to even be a thing, the function can't exist there. That's not true. I could give you a problem where it actually works, and you can get an actual number here. The point is that it's still approaching a number. But the reason I use this example is because I want you to understand that the limit of a function is not what the y value is, it's what the y value is approaching. Okay, so a limit is something you are getting closer and closer to. So the limit is the y value of your function, represented by L. Well, the limit is the y value that your function is approaching as x approaches c. So that's what a limit is. Okay? So I wrote it out in less mathy language, but I've already been explaining it in less mathy language, so I'll just state it again here. The limit of a function is the y value it approaches as the x value approaches some value. All right. Now, as you guys saw from our table here, we approached 3 from numbers that are less than 3, so that would be from the left, and we also approached 3 from numbers that are greater than 3, and that would be approaching from the right. So now a limit is approaching from the left and the right all at once, but you could have one-sided limits. In that case, if I write a little plus right here, that means I'm approaching c from the right. So back to our slide here that we started off with, that would be this side. So on this side, this is the limit as x is the, well, actually, instead of saying the limit, what we can do is we could say here it's, if we're on this side, that means we're approaching c, the number 3, from the right, because that's on the right side of the graph, and we use a plus to denote that. Whereas if I'm approaching my c value from the left, we would write it like this. Oops, I guess we're put 3 there. All right, so that's what we call a one-sided limit. So a regular limit is both sides. We're coming from the right and the left. But a one-sided limit, they'll use a little plus or a minus to indicate whether we're coming from the left or the right. Now all of these have a purpose. Sometimes we want to just approach from the right. Sometimes we want to approach just from the left. But usually when we're talking about limits, we want to know what the function's approaching from both sides. Okay? Now, let's go ahead and take a look at some other situations here. All right, so we're going to share with you guys a few facts about limits now. Now, if the limit from the right is L, meaning if I'm approaching c from the right and the y value goes to L, and if the limit from the left is also L, Let's do my circle a little differently. So if the limit from the left is also L, in other words, as I approach C from the left, the y value still approaches L. Let's see what that would look like on a graph. So let's say this is my y-axis and this is my x-axis. And I'm approaching that point from the left, and I'm approaching that point from the right. And I would encourage you guys to draw this picture here on your notes. In this case, the limit from the left and from the right, the y value, they're both approaching the same point. When the limit from the left and the limit from the right are both approaching the same y value, that means the limit exists. You guys remember that little movie from gosh, it's been a while now, but a lot of students still remember it, is that Mean Girls movie where it says, the limit exists. Well, the limit does not exist. Well, this is what they're kind of talking about. Limits can either exist or not exist. And here's when a limit exists. The limit exists when, whether we're approaching from the right or the left, we actually get the same y value. We're approaching the same y value. So whether you're approaching from the left or from the right, you're approaching the same y value. In that case, the limit exists. Let's look at some times, though, when the limit does not exist. Well, actually, I guess we're not going to do that yet. We'll get to that in a minute. So here we go. We're going to evaluate the limit by completing the table below. All right, now let's begin. So we want to approach 1 first of all. So let's identify the fact that I want to approach 1. Now I'm telling you right now that if you tried to plug in 1, it's not going to give you an answer. The function is undefined. But I just want you to remember, just because the function is undefined, that doesn't mean that we're not approaching one specific y value. In other words, that doesn't mean that the limit doesn't exist. So even though the function may not exist at this point, the limit may exist. Okay? So let's start approaching 1 from the left and from the right. Now, here's the deal. We're going to pick some numbers to the left of 1, but the idea is we want to get closer and closer to 1 as we go. Now, if you don't pick really, really close numbers, sometimes you'll miss the entire picture that we're trying to see. So here's a pretty good rule of thumb to go by. To the left, we're going to subtract 0.001. In other words, I'm going to subtract 1/1000th from 1. And then here I'm going to subtract 1/100th from 1. And here I'm going to subtract 1/10th from 1. So now on the right side, though, we're going to do the same thing, but instead of subtracting, we're going to be adding, because as on the right side, the number should be bigger. So I'm going to add 1/1000th to 1. And then I'm going to add 1/100th to 1. And then I'm going to add 1/10th to 1. Okay? So that way, we're getting close. When we figure these out, you're going to be getting numbers that, as we close in this way, these values are going to be getting closer and closer to 1. Okay? So, because that's what a limit is, remember. A limit is this concept of approaching something, getting closer and closer to something. All right? So let me bring up my calculator here really quick. So let's find out what this spot is right here. The first thing we're going to do that is we're going to enter the main C value that we have, which is 1, and then I'm going to subtract 0.001. I'm going to subtract 1/1000th from it, and that gives me 0.999. Okay? And then I'm going to do the same thing for the next spot. I'm going to put 1, but this time I'm going to subtract 1/100th, or 0.01. Not surprisingly, I end up with 0.99. And then we're going to do the last one, which you guys can probably predict is going to be 1 minus 0.9, which is, no, that's not right. It's 1 minus 0.1. Sorry, not 0.9. So that would be 0.9 is the final answer there. So as we subtract these values from 1, right, we get those answers here. And as you can see, these x values are getting closer and closer to 1. 0.9 is really close to 1, but 0.99 is even closer. And 0.999 is so close it's hard to tell how it's even different from 1 at all. But there we are. So we're getting closer and closer to 1. Now on the other side, in this case, it's a little bit easier. You're just going to do 1 plus 0.001. And that's 1.001, obviously. Sometimes adding's a little bit easier. So in this case, I could probably just do it mentally, right? And the same thing is happening on the right side now. 1.1 is really close to 1, right? But 1.01 is even closer. And 1.001 is so close, it's really hard to tell how they're really different numbers at all anyway. And so what's happening is we're getting, by adding these values and subtracting these values on the right and left, we're creating x values that are getting closer and closer to 1. These are x values that are approaching my c value from the right, and these are my c values that are my x values that are approaching my c value from the left. Okay, so that's the first thing that you need to do. Now we're going to be, doesn't have to be all that hard, honestly, but I'm explaining a lot, and so along the way you guys might feel a little overwhelmed. So I'm going to write some steps here. And that way you guys will have something to kind of look at when you guys try this. So our first step is to add and subtract. Add is on the right, subtract is on the left, the following three numbers. 0.001, 0.01, and 0.1. So you're going to add and subtract those numbers from the c value. Okay, and that's how you're going to complete your first row. All right, now the next thing is we're going to find the y values by plugging in each of the x values. So plug in each x value. Plug in each x value to the function. To find each y value. Now for this step, we're going to use our graphing calculators to do this because it would be a horrible, tragic waste of time to sit here and plug in a number like 0.999 and then try to simplify that. And so we're not going to do that. It's a terrible waste of time. But it's still, the reason I want to do it, at least on the graphing calculator, is because I do want you guys to know how to use the graphing calculators in that way. So now that I've got my x values from step 1, step 2, we're going to find the y values that go with each of those x values by plugging each x value into my function. This is my function here. And so we're going to be plugging 0.9 in, we're going to plug in 0.99, we're going to plug in 0.999, etc. And we're going to find the y value that goes with all 6 of those x values, okay? Let me erase all my stray marks here. All right. And so those are your 2 steps. I erased more than I wanted to there. Those are your 2 steps so far. Maybe we'll have a 3rd step in a second. But let's go ahead and plug these numbers in. So I'm going to show you how to do that in the graphing calculator. And I believe it's something we've already done. Okay? So it shouldn't be too much of a big news situation for you guys to figure out how to do this in the calculator. The first thing we're going to do is we're going to push y equals. Clear out anything that's already in there. Next, we're going to enter our function. Now, our function is this thing right here. Okay, so I want to enter x cubed minus 1. Now you have to put that in parentheses. So x to the power of 3 minus 1. Since it's all in the numerator, we have to put that whole thing in parentheses, and then we push divided by x minus 1. And remember, oh, and that has to be in parentheses also. And remember, there is a difference between the minus button and the negative button, so don't get those mixed up. All right, so I've got my function entered. Now I'm not going to graph it. I'm going to actually go to second quit. And I'm going to go back to my home screen. So you push second and you push quit and you go back to your home screen. Now what I'm going to do is I'm going to have my calculator plug each of these x values in. So here's how we do it. We push vars, V-A-R-S, and that's in the third row down, fourth button over. And then we're going to scroll over to where it says y vars on the screen. And we're going to push 1 where it says function. And we're going to select y1. Then we're going to put parentheses. And this is where I'm going to plug in my very first x value. I'm going to plug in the 0.9. So here we go. I'm going to type 0.9. I'm going to close my parentheses. And that's telling my calculator I want to plug 0.9 into that function and enter. Now that seemed like a lot of work, but trust me, now that we've done that, the rest of them are going to be extremely easy. So that's 2.71. Now, we could go through all those steps again. I could push vars, and then I could push 1, and etc. and just kind of keep doing the same thing over and over again. But I want to show you guys something kind of useful on the calculator which makes life a little bit easier. Go ahead and push second, and then push the enter button. Whatever was the last thing you typed in, it brings it right back. And now what I can do is I can just back up a little bit and type in my new number. So I want to type in 0.99 instead. So now I'm going to back up and put 0.99. And that way I don't have to push vars and go over and all that good stuff again. I can just recall what I had, and it's a little bit faster. Enter. So now I get 2.97. All right. Let's do it again. Second, and enter. And now I want to plug in my next x value, which is 0.999. So 3 nines. Now I get, for an answer, 2.9970. How far do we have to go? Well, you know, as many as you could squish in the box. Let's say that. 2.997, and that's as many as I can squish in there. All right. Continuing, now we're going to do the other side. I'm going to plug in 1.001 now. Okay, so, and I'm just going to keep going. There's not much more after that to do other than just continue to do that. But that's not going to be our answer. We'll have to interpret it at the end. But as far as the calculator work goes, I've given you all I can give you at this point. And I'm just going to keep going. You can push, now if you ever want to delete something, you can put your cursor on top of the number you want to delete and just push the DEL button. First row there, third button over. All right, so we've done it. So let's review our steps really quick before we move on, because I want to make sure you guys got the idea. So the first thing we did was we found our x values. We found our x values by subtracting 0.001, 0.01, and 0.1 from 1. We found these ones by adding 0.001, 0.01, and 0.1 to 1. And then to find our y values, we just plugged each one of those x values in, and we got it. So now what do we do? Now we're going to interpret our answer. So let's remember, what is a limit? Okay, well, a limit is something where as x approaches a certain value, in this case c, x is in this case 1. So as x is approaching 1 from the right, and as x is approaching 1 from the left, the question is, what is my y value approaching from the left and the right? Well, let's see. So as I approach from the left, on this side, 2.71, 2.9701, 2.997. What number does that seem to be getting closer and closer to? Well, it seems to be getting closer and closer to 3. How about on the other side? What's the y value getting closer and closer to? Well, let's see. It starts over here. We start from the right, and then we work our way towards the center there, right? So 3.31, 3.03, and 3.003. It looks like it's also getting closer and closer to 3. Okay? So here's how we'll write our answer. Okay? The limit as x is approaching 1. Now I'm not going to put a plus or a minus here because when you're talking about a limit, that really means from both the left and the right. And so we don't put a plus or a minus there if we're talking about left and right at the same time. So the limit as x approaches 1 of this function here is equal to whatever that y value is that it's getting closer and closer to. Well, the y value is getting closer and closer to is 3. And so here's our answer. There's our final answer. All right? So step 1, find your x values. Step 2, use the calculator to find your y values. Step 3, I'll write it down. What y value are we approaching? That's the answer. Now, it has to be approaching the same y value from both sides. So if it's not approaching the same y value from both sides, well, then we have a problem, and we'll talk about that. But there it is. All right, so we're going to do a guided practice, and what this means is I'm going to be asking you guys to do one step at a time, pausing the video and trying it on your own, because there are a lot of steps here. All right, so the first thing I want you guys to do, if you need to, is pause the video, and I want you to look at the problem that they gave you, and then I want you to decide what number goes here. Pause the video and see if you can figure that out. All right. So, well, that's the x value I'm approaching. And from the problem up here, I can see the x value we are approaching is 0. So I'm going to put a 0 there. Now, I've already done the work for you, and I'm going to put a sad face here because if you plug 0 in, the function doesn't exist there. Now, I want to remind you, that's not always necessary. You could still have a limit with a function that exists at that point. I just feel like functions that don't exist at that point make the point better that limits are not what the function equals at that point, but rather what the function is approaching at that point. So that's why I like to pick ones like that. But anyway, so there's that. Now what I want you guys to do is I want you guys to find these 3 x values and these 3 x values. So pause the video and see if you guys can figure out what those x values are. All right, so there's our x values. Remember, to find the x values on the left, you're going to subtract 0.001. You're going to subtract 0.01, and you're going to subtract 0.1 from your c value. Now, if you do 0 minus 0.001, you just get negative 0.001, and that's why we have this number here. And if you subtract 0 from 0.1, you get this. And if you subtract 0.1 from 0, you get that. So that's where it came from. And the other side, you do the same thing. You just add it instead of subtracting it. And so those are the x values that we get. And those are x values that are approaching 0 from the left and from the right. And they're getting closer and closer to 0 as they close in. All right. Now the next thing we need to do is we need to find our y values. Now the way you do that is by using the calculator. Now for this one, we'll break this step up into a few different steps. So here we go. Let's go ahead and first of all, I want you guys to enter the equation. So push y equals and enter the equation. Now don't get ahead of yourselves. Entering this equation is a little bit tricky. If you don't know where the square root button is, it's under the math here, where you're going to click math on the first column there, third button down, and you could see, well actually, I take that back. there's a better way to get it. Just push second and then the x squared button, which is the 5th button down on the far left, and that's your square root. But you have to enter this thing correctly into the y equals section here for y1. So you guys need to type that into your calculator. So what I'm going to do is I'm going to ask you guys to pause the video here and see if you guys can accurately type that function into your calculator. Alright, so here's how this works. X, now you could put the x in parentheses if you want to, it doesn't really matter because it's just one term. Divided by, now the entire denominator needs to go into a set of parentheses. So I'm going to start with parentheses. Did you do that? If not, make a note to yourself. Next, I'm going to enter the square root button. So second, x squared gives me the square root button. And then x plus 1. Then I close the parentheses. Now that parenthesis that I just closed, that puts the entire x plus 1 underneath of the square root. But remember, I still have this parenthesis over here, and that's for the denominator. I'm not done putting the denominator in yet. So I still have one more thing I need to put in the denominator, and that's the minus 1. The minus 1 is not underneath of the square root, though, but it is in the denominator. So we're going to push minus 1, and then we close the parentheses for the denominator. So that's what it should look like. Now, some of you guys have really nice calculators where literally if you just type it in correctly, it will look exactly like that. That's cool. I like those calculators more, but some of us have these little ghetto buddies here, and we have to deal with them. So, all right. So now you guys are going to start finding your y values. You're going to start finding your y values. So, see if you know how to go back to the home screen and start entering the y values to get those. Okay. Pause the video here. Now, if you had trouble even getting back to the home screen, remember you push second, and then you push the mode button, which is quit at this point. And then you're going to push vars, V-A-R-S. You're going to go over to where it says y vars. You're going to push 1, and you're going to push 1 again. Now we have our y1, which is our function up. Parentheses, and we enter our first x value, which is negative 0.1. Now remember, there's a difference between a negative and a minus button. The negative is at the very bottom row there. So it's negative 0.1. Enter. And so that's the very first y value that I'm going to put in, is 1.949. Okay? How do we bring up the next one? Well, you push second and enter. And so the next one I'm going to enter is negative 0.01. So go ahead and do the rest of them if you haven't already. And if you have, awesome. Just chill for a second and we'll have the answers up in just a second. All right, guys, and there you have it. Those are the y values that you should have gotten by using your calculator. All right, now I want you guys to fill in the blank here. What does the limit equal? Well, as you guys can see here, as I approach from the left and from the right, my y value seems to be getting closer and closer to the value of 2. So the limit of this function as x approaches 0 is 2. Or in other words, the y value I'm approaching as x approaches 0 is 2. All right. So now that we've done a guided practice, I'm going to let you guys do one here. You're going to make your own table. Now the beginning of it is pretty much just generally going to be the same. We're going to have an x value here, and then we're going to put our function value here. We're always going to have 3 on the left, a middle one, and then 3 on the right. And once again, the function's not going to exist at this point. And from here, I'm going to let you guys go ahead and start finding that limit by completing the table below. When you unpause the video, you will see the solution. All right. So on the right there, I've got my calculator, so you can see how to accurately put the function into your calculator. If you got error at any point, once again, you might have mixed up by putting a negative button instead of a minus button. You got to be careful with that. The x values are what you see there in the top row, left side. We got those x values by subtracting 0.001, 0.01, and 0.1 from 2. And then on the right side, we added those same values to 2. And then we plugged them in using our calculator, and we get these values here. And as you guys can see, whether we are approaching from the left or from the right, both y values seem to be getting closer and closer to 1 on either side. So the limit is 1, and your answer goes right there. So the limit of this function as x approaches 2 is 1, because the y values approach 1 from the left and right. Even though the function doesn't exist there, the function does have a limit. It is approaching a number at that point. Okay? All right. So now let's take a look at some other scenarios here. So now we're going to look at some situations where the limit doesn't exist, where something goes wrong in the process. All right? So in this case, limit fact number 2, if the limit from the right and the left are different, then we would say that the limit of that function does not exist. Now here's how you would write this mathematically. This represents the limit as we approach as x approaches c from the right, and this would represent the limit as we approach x approaches c from the left. And in that case, the inequality in the middle would indicate that they're not the same. That would actually mean that the limit does not exist. Now each one of these one-sided limits exists, but the limit, which has to be both of those put together, does not exist. And in that case, I drew a line here. So as we approach from the left and we approach from the right, we're approaching two different y values. One may be higher or lower than the other. And so the limit doesn't exist. Since we're approaching two different limits, you could just imagine that little guy saying, well, I don't know what I am because it's different on different sides. So you can't really give an answer since there's different answers. You could give the answer for the right, you could give the answer for the left, but you can't give the answer for the limit overall. And so that's one way that a limit can fail to exist. Okay, so I want you guys to go ahead and do this problem here. Now, as you guys do it, you're going to need to know where the absolute value function button is on your calculator. The absolute value function button on your calculator is under the math button. So you're going to push math, then you're going to scroll over to where it says NUM, and then you're going to click number 1 for ABS. And then after that you're going to put X, and then divided by, and then on the bottom we just have X. Okay, so that's how you'll put it in your calculator. But once again, that's math over to num and then 1. Okay? But anyway, yeah, there. So I'm going to let you guys set your table up and complete the table, and then we'll analyze the results when you're done. So pause the video here, and when you unpause it, you'll see a completed table, and we'll talk about the results. Alright guys, so as you can see here, this is your table set up, and now something really interesting is happening here. It's not getting closer to something, it just literally equals something the entire time. Whether you're coming from the left or from the right, it's constantly -1 over here on the left, and it's constantly 1 on the right. So here's the problem. As you're graphing these points, you know, we're approaching x equals 0, right? And at -0.1, which I'll put right here, right? And here's -0.01, here's -100. At -1, at -0.1, we're at -1. At -0.01, we're there, and at -0.001, we're here. And so we're approaching a value of -1 on the left, but on the right side, if I put 0.1 here, and 0.01 here, and 0.001 here, the y value is 1 the whole way across, so it's coming this way. So we're not approaching the same y value from the left and from the right. And so this is an example where the limit does not exist. And we can actually, I think it might be wise to go ahead and state the reason here too. And I would include this in your notes. Okay, so there's our explanation. because the left and right hand limits are not the same. All right, let's go ahead and move on to another problem here. Limit fact number 3. So we've looked at limit fact number 1, that if the limit from the right and left approach the same value, the limit exists, and the limit is the value that they approach. Limit fact number 2 is that if the limit from the left and right are not the same value, then the limit does not exist. And then limit fact number 3 is a new one as well. If the limit from the right or the limit from the left are infinity, then it doesn't exist. Now, this is kind of strange. So let's just say we have here's the c value I'm approaching. Now, as I approach it from the right side, the y values just get bigger and bigger and bigger. They never reach, we can't get to c, but as we do, the y values just shoot up into infinity. Same thing on the left. It's kind of like what happens, actually it's exactly what happens when you have a vertical asymptote. Okay? Now in that case, we would say that the limit is infinity. But that still means it doesn't exist because we're not approaching a value. By the way, on your notes, I would encourage you guys to draw this picture because that's what that indicates. The limit on the right is infinity, the limit on the right is, and on the left is infinity. And since it's the same on both sides, we could say, okay, fine, the limit's infinity, but that still doesn't exist. Okay, just so you know, because it's not approaching a number. All right, let's take a look at yet another example. In the same way, as you approach from the left, it could be going to negative infinity. Or as we approach from the right, it could be going to negative infinity. If it's doing the same thing on both sides, then we could say, okay, fine, the limit's negative infinity. The y value is going far and far down, so it's negative infinity. It never reaches anything. But still, the limit doesn't exist. So we could say positive infinity and negative infinity to be more specific, but we just can't say that it exists. Okay? So let's look at one final limit fact number 5. On this one, if we're approaching c from the right and you get one kind of infinity, but then you approach c from the left and you get a different infinity, in other words, one of them is positive and the other one's the opposite, negative, well, we're not going to say that the limit is infinity anymore because we don't know which one to pick. So at that point, the best we could say is it just doesn't exist. And the way that that would look is like maybe on the left side it goes up, while on the right side it goes down. Or another way that that could happen is the opposite. You could have it on the left going down, but on the right going up. Either way, since it's positive infinity on one side and negative infinity on the other, then we just can't say that the limit exists at all. Okay? So, just to review, there are two ways, basically, that we can end up with a non-existent limit. The first way is if the limit from the left and right both have numbers there, they both approach a value, but they're just different values. Another way you could tell is that the limit doesn't exist is if you end up with an infinity on either side. But even though that means that they don't exist, if they're the same kind of infinity, instead of just saying they don't exist, we can actually put positive infinity if they're both positive infinity, or you could put negative infinity if they're both negative infinity. But if they're opposites, then we just still have to just say, okay, fine, it just doesn't exist. Okay? And so we have one more set I'd like to go through here. I would encourage you guys to pause the video here, set up a table, and let's take a look at what it looks like when you're setting up a table to see what the whole infinity thing looks like. Because your calculator's not going to give you, it's not going to say infinity, okay? But you can tell it's infinity, and I'll show you how. So go ahead and set up your table, and then when you unpause the video, I'll show you the tables, and then you can interpret the results along with me. All right, let's go ahead and take a look at our results here a little bit. So we're approaching 0 from the left and right here for the x value. Now let's look at the y values though. The y value is not getting closer and closer to anything. It's actually getting big really fast. Okay? Same thing on the right. So here's what's going on. As I approach an x value of 0, which is right in the middle of a graph, right? If I call this spot over here 0.1, and I call this spot here 0.01, and I call this next one here 0.001, and those are the negatives. right? Same thing on the other side, but with a positive. So let's graph these points. Like at negative 0.1, I'm at negative 10. So let's just say like negative 10's right here. And then at negative 0.01, well, that's negative 100. That's going to be like 10 times farther down. And then at negative 0.001, it's going to drop down 10 times farther than that. So what's happening is as we get closer and closer to 0, this thing's dropping super fast. And on the right side, the same thing's happening, but it's just happening on the opposite side. So as at 0.1, it's positive 10, and then it's 100, then 1,000, so it's shooting up really fast like that. So what that means is that you don't have to draw the graph. That takes a lot of time, but I'm just helping you to understand what the numbers look like and what they mean. So since this side is just getting bigger and bigger and bigger without any indication that it's getting closer to anything, it's just increasing. Actually, it's decreasing because they're negatives. Then the limit from the left is negative infinity. And on the right side, the number's getting bigger and bigger and bigger on the right side, and they're approaching positive infinity. Okay? And so since the limit on the left and right are infinities and they're not the same, then the only thing we could say for this one is it just doesn't exist. Okay? Now let's take a look at the next one. Now in the next one, before I talk anymore, you guys might get something like this on your calculator once in a while. And what that means in science class is scientific notation. It means 1 times 10 to the 6th power. In other words, what that really is a million. Now some of your calculators might have just literally put a million. But some calculators, they just kind of get sick of such huge numbers and they turn it into scientific notation. But that's what that means. It means a 1 with 6 zeros after it. So that's a million. So as you can see, the same thing's happening here. This thing is increasing super fast. It goes from 100 to 10,000 to a million as we get closer and closer to 0. Now that's positives though, right? So we're shooting up into positive infinity as we get closer and closer to 1 on the left. And on the right side, the same thing's happening. It's the same exact numbers actually. So they're both positive infinity. Now technically this one doesn't exist either, but we can be more specific and say, well, it doesn't exist, but the limit's infinity because it's going up on both sides without any kind of boundary being reached. Okay? And so that is what it means to have infinite limits. So we've looked at 5 situations now. One of them is what a limit is. When something as you approach C from the right and from the left, if you're reaching the same y value, the limit exists, and that limit is the y value, which is L. But another situation is if they're both, even though the right and left limits both approach a specific number, they are getting closer and closer to something, but they're not approaching the same thing. That's one way that the limit can fail to exist. The other way is if you have infinities involved. But if the infinities are the same on the left and right, we can say infinity or negative infinity depending on whatever they are. Sorry about that. I was teaching a class, but that was sweet. All right. Anyway, but if they're not the same on the left and right, then no limit. Cool? And that's limits for you. So we'll stop there and call it a day.